A review of reflection. Highly smooth or polished surfaces, like a large calm body of water or the polished surface of a mirror, reflect light regularly, as opposed to rough objects which spread out or diffuse the reflection. Only regular reflectors can form images. Let us recall some basic principles of reflection from yesteryears. We know that the angle of incidence is equal to the angle of reflection when measured with respect to the normal. We also know that the incident ray, the normal, and the reflected ray all lie in the same plane. It is important to note that these laws are applicable to all types of reflecting surfaces, whether they are rough or smooth, plane or curved. In a plane mirror, the image appears as though it has been formed at some imaginary point behind the mirror. It is virtual, erect, and the same size as the object. Further, the image is also laterally inverted. Left stands for right and vice versa. To reiterate, these laws are as applicable to curved surfaces as flat surfaces. They are as applicable to rough surfaces as smooth surfaces. But if that is true, what is all this regular and irregular reflection business? Shouldn't all surfaces reflect the same way? Let's break apart these laws to understand what they really mean. Notice the law does not mention anything about the angles that these rays make with the surface, only the angles that they make with the normal. The reason is the plane surfaces that we have dealt with have parallel normals, meaning that the sets of incident rays and reflected rays will be parallel if the rays are coming from infinity. Things change when we have to deal with curved or irregular surfaces. For one thing, the normal at each point on the surface is no longer parallel to the other. This means that the reflected rays are no longer forming any coherent pattern, and as a result, they cannot form a useful image. On the other hand, spherical mirrors reflect light in a predictable and coherent pattern. Let's figure out the rules for such mirrors.